Hello, Malcolmites. Welcome. Hope everyone is reading well. So, we should look about the basics of laser. Okay, I'm not going to talk about in depth about lasers, the types of lasers. Everybody would have known the types of lasers, the wavelength of lasers. Yes, of course. This is just a very short video explaining the basics, the physics of laser. Okay, so light amplified stimulated emission of radiation. Okay, so what is this laser? What is this principles of this laser? Because the principles is going to be a little bit confusing for most of them. Okay, we would have read what are the types of lasers, what is the wavelength of laser, what is the effects of laser on various soft tissues and hard tissues, and what is the the classification, the everything in depth about lasers. Okay, the uses, the advantages, the disadvantages of lasers, everything. But when it comes to the principles of physics of laser, it will be very little bit confusing. Okay, I'll just refresh it out. Okay, now you have to understand that an atom will have electrons in the innermost shell. Okay, the atoms will have electrons in the innermost shell and the outermost shell as well. Okay, so whenever an incident photon hits the atom, what is this incident photon? It's very simple. In this case, in the laser, a light. Whenever a light, right, that's what it is, light amplified. Okay, whenever a light hits an atom, we call it, that is the incident photon. Whenever it hits atom, what happens is basically there is going to be the shift of electrons from the lower energy state. Okay, which is the lower energy state here? This is the low energy state, and this is the high energy state. There's going to be shift of electrons from the lower energy state to the higher energy state. And then what happens at some point of time, say for example 10 to the power minus 8 seconds, it comes down. Okay, so this type, whenever an incident photon comes and hits an atom, it's going to shift the electrons from the lower energy state to the higher energy state. This type of transmission, this type of emission is called as spontaneous emission. So what happens when an incident photon comes? It is going to result in the shift of electrons from the lower energy to the higher energy. And again, at some point of time, it will come down back to the lower energy. And while coming back, it releases a photon. This is a normal spontaneous emission of photons, spontaneous emission of energy. Okay, so this is the lower energy state, this is the upper energy state. Say for example E1 and E2, or E2 E1, whatever you call it. So the electrons from the E1, this is the low energy state, this is the higher energy state. So whenever an incident photon hits it, the electrons from the lower energy, it is going to get shifted to the higher energy, and at some point of time it will come down to the lower energy state and release photon. While coming back, it releases a photon. This is a very basic principle. This is the spontaneous emission. Okay, this is spontaneous emission. Very important terminology, potential MCQ. Now, what happens in stimulated emission? Okay, in stimulated emission, what happens is the electrons from the lower energy state, okay, this is E1, this is E2, lower energy state, higher energy state, and whenever an incident photon hits the lower energy state, it is going to shift to the higher energy state. Very important. Listen carefully. In this stage, what I'm going to is, rather than the photon itself coming back to the lower energy state at 10 to the power minus 8 seconds, it is very less. so that you don't get that sufficient amount of time, the sufficient amount of energy to be specific. Okay, it just goes to the higher state. Within 10 to the power minus 8 seconds, it comes down. Very less amount of energy is released. So I want more energy to be released. What I'm going to do is I'm going to stimulate it. I'm going to stimulate it to release more energy. So what can be done is, if I'm going to keep that electron for a little bit of longer time in the higher energy state, then I'm going to get a little bit more energy, isn't it? So what I'm going to do is I'm going to leave an incident photon on the atom. So the electrons from the lower energy state shifts to the higher energy state. And now you have to understand one thing. I'm going to give another photon, another incident photon in the higher energy state. So what happens now is the electrons, instead of coming down to the lower energy state directly, in case of a spontaneous emission, here it goes to another state called metastable state. It goes to another state called metastable state. So what happens? This electron comes here and then it comes here. So this photon, which is released as usual, this photon will be released, and another incident photon we are applying, right? That will also be released. So two photons will be released in case of the stimulated emission. So we are going to keep the electrons in a higher energy state for a little bit of longer time. So I'm going to apply another incident photon. I'm going to energize the electrons. So what happens? I'm going to get more amount of photons, more amount of energy. So that is what the term light amplified stimulated emission of radiation. Okay, this is a very, very basics of lasers. It works on the principle of quantum physics. Okay, so definitely you should understand this before moving into the lasers. And once you understand this, the wavelength, the type of lasers, everything will be very easy for you. Okay, so yes, thank you for watching this video, and keep reading, keep revising. Please put a timetable and read, because if you read it haphazardly, then you're not going to finish the subject. You'll end up somewhere, you will not know where you're going. Okay, always put a timetable, always know what you're reading, and always complete the task you have kept for a day. For example, if you're in your timetable, you have put some schedule for 11 hours, definitely try to complete the 11 hours, at least 10 hours. Okay, if you put the timetable for 11 hours, you read only 3 hours a day, then there is no point in putting the timetable. Then you put the timetable for 5 hours, you try to bring that 3 to 5 hours initially, then come to 7, 8, 9. Don't, if you are about to start the preparation, never read for 12 hours or 13 hours a day. No one can read. Okay, if you are consistently doing the preparation for 7 to 8 months, yes, you can do that. But initially, it will be around 3 hours to 4 hours only. Don't get discouraged, don't get demotivated. Yes, you can. Everybody starts a preparation like that only. Okay, so all the very best. Keep reading, and we'll see you in the next video. Bye.